Hello, I'm Tiffany Trader, Managing Editor of HPCwire, and here with me today is Vivek Mahajan, Senior Executive Vice President and Global CTO at Fujitsu. Welcome, Vivek.
Welcome, thank you. Thanks for having me today.
Thanks for joining me here today.
Pleasure.
So,
Pleasure.
I understand that you've been with Fujitsu pretty much exactly a year now. That's right. So, can you tell us about your role with the company and what your areas of responsibility are?
So once again, many thanks for having me. End of this month, I'll be exactly a year in Fujitsu. My role in Fujitsu is as the global CTO, Chief Technology Officer. What that means is I'm responsible for pretty much the technology direction of Fujitsu, where it's headed, what technologies we invest in globally, strategically, where we partner versus this is what we build. So anything related to technology, kind of the buck stops with me in Fujitsu. Yeah.
Great. And I understand that there's two particularly special projects and focus areas that you've been working on. One of them involves Quantum, and then the other one involves HPC as a service. Could we start with Quantum? I believe you have a project that you've been working on with Riken and using the Fugaku system, and of course Riken and Fugaku are a close partner because you developed that A64FX processor that's key to the Fugaku system together. So what have you been doing with a quantum simulation with Fugaku and Riken?
The couple of things that we are doing in the quantum area overall, right? If we look at the Fujitsu strategy, we've got, as you mentioned, HPC. We do a lot of work in digital annealer and then quantum simulator and then pure quantum. With the quantum simulator, actually pretty much a Fujitsu homegrown thing, right? What we did was we took the A64FX processor, which powers Fugaku, and Fugaku is really a building block of FX1000 machines, and what we decided to was we ported the quantum simulation software that's there in open source with one of our university partners, and we ported on that to build the fastest quantum 36-bit quantum simulator that we announced to the world at the end of March. So what that does is that enables companies and organizations and industry players to actually start building their applications, looking at applications without really waiting for quantum to arrive in a stable form, which will take some time. And we also took a very unique approach this time from a research perspective. When we thought about it, we went to a couple of industries like Fujifilm, and said, what do you think about it? And they were actually pretty excited, and they've actually started using it to do some of the molecular analysis work that they are doing, right? So that's what we're doing on quantum simulator. On the quantum side, we're actually working with Riken to build a gate-based quantum computer, as well as a couple of other universities like Delft in Hong Kong on diamond spin and trapped ions. So we're looking at the whole gamut.
Oh, great. So how do you see HPC and quantum fitting together?
Our view of the world is that not much as quantum is needed, and quantum will help solve some very difficult problems. It's not going to be a world where everything is going to be quantum or everything is going to be HPC. I think there'll be appropriate workloads for different kinds of computing that are best suited on those platforms. And we also believe there's a path forward for our annealing solutions and quantum simulators just because of the cost performance. At the end of the day, you have to think, Tiffany, you have to think from a perspective of an end user really shouldn't have to care about where should their problem be solved, which kind of compute solves their problem. Should it be quantum or should it be HPC? In fact, would a banker really care or even know the technology in that detail? They won't. So what we are looking at is all they should care about is the problem is solved in the fastest possible manner, gives the most accurate result at a minimal cost. And so we're kind of trying to build a middleware on top of it that goes on, on top of HPC and quantum-like solutions, where the user can throw problems at it, and it'll automatically parse that problem to the best possible compute that is suited for that problem, and gives the answer in the fastest possible manner with most accurate answer at the minimal cost. So we see a world where HPC and quantum will coexist moving forward.
Mm-hmm. And at the system level, how do you see quantum fitting into the system? Some folks are talking about quantum as almost like another accelerator as part of the HPC system.
That's an interesting thought, and it's a good question. I mean, I don't know whether it'll be an accelerator for HPC system. I think that there's obviously some problem, like traveling salesman problem, that is best solved on quantum, right? So there are some very nutty problems that take a lot of time that are not necessarily suited for HPC or traditional compute. So I'm not sure whether that's just an accelerator for HPC. I think there is a very viable potential for quantum as its own independent form of computing, but it won't be, and I don't see it just in HPC. I think even normal compute. By the way, we look at HPC as democratizing it and being used in a much wider space. But I think they are two independent computers, and they also can be very interrelated, but that's how we see it.
Mm-hmm. And what you're talking about, having a system and an interface that can run the workload where it needs to be run, it sounds like that may fit in with HPC as a service too, which I know is another project that you're working on, and you've announced, I think Fujitsu has recently announced within their portfolio some HPC as a service offering. And I believe that's also part of the Fugaku project as well. Could you speak to that?
Yeah. So what we announced was compute as a service, and when we came up with this concept, the whole vision was, look, you have HPC, and HPC traditionally, or even I try not to use the word supercomputer because then people get the image of it's like white people wearing white coats sitting in labs with white beards. No, the power of HPC should be used in a much wider by a much wider community and end users to solve the day-to-day problems. And I think HPC has that potential, and technically it's not it's absolutely possible. What has been preventing from that vision being actualized is the cost. So what we did was we took HPC, we took our digital annealing solutions, we took our quantum simulator, we took our AI platform, we said we're going to make that available to whoever wants to use it over Amazon and Microsoft Azure cloud platforms. So suddenly the cost becomes, you only pay for the compute cycles you want to use. And that's the whole simple concept between compute as a service. And HPC is obviously the first part of that. But when quantum comes to a point where it's stable and being ready to plug in, and what I recently mentioned about the computer workload broker, if we can get that from a research project to a real, actual commercial grade, then that would be fantastic. I mean, it will help solve a lot of problems for users while not paying, hey, I need to have a quantum computer sitting in my backyard and a HPC, a supercomputer, and I mean, not many people can afford it. And even if you can't afford it, you're not going to pay, capex for that, right? So I think the cloud vendors and partnering with that is going to help us deliver that.
And your compute as a service, is it hybrid? Does it work with the big cloud providers? And then does it also work with the Fujitsu on-prem hardware?
It uses the on-prem hardware, absolutely. So if somebody wants to say, I do not want cloud, absolutely you can have that. But as I mentioned, it works now with AWS and Microsoft Azure. And there's no issues in making, for example, making it available with Google. If that's what there's overwhelming demand from the users. So it's really being demand driven. We see a lot of demand on having this available to customers on AWS and Microsoft.
Is this something that Riken and Fugaku are leveraging?
Riken and Fugaku, you have to think of this, I would say, as two different things. Riken and Fugaku the Fugaku is a cluster of massive, a lot of FX thousands. So that's primarily a solution which caters to a specific demand. But Riken has the same vision of making compute available via cloud. Okay, so in fact, I was just talking to them yesterday on similar concepts, and they were like, I think the vision is totally aligned where we are.
All right, so you have the A64FX, and you have is it the FX700 and the FX1000?
Those are boxes.
Right, that's your server products. Any hints about what's next on your roadmap? What direction? And those are ARM, by the way. Those ARM based.
Yeah.
Developed in collaboration with.
A64FX is ARM based. The next processor, as we announced, is MONAKA, Fujitsu-MONAKA. That's we chose a very different name. MONAKA is a kind of suite that's loved in Japan, and it's with that goal that it should be a much wider used system. So Fujitsu-MONAKA is our chip that we announced to the world in end of February. It will also be ARM-based. It will challenge the latest and greatest in the chip technology and CMOS technology. It will challenge the foundries, where it'll stretch them to the limits as well. The key point is that processor will be is suited for data centers. With the goal of using power consumption that's 1/10 of what A64FX uses. So it'll be very, very environmental friendly. Secondly, it'll be focused on very wide set of data sets. So anything that runs on ARM will run very well on this. And we're hoping at some point in time, even our ISVs like SAP would start running on ARM, and that would help address a demand that the users have and give them an option, and that will run very well on MONAKA as well. So that's our if we announce this, that's where we're headed. And then I guess from there on we'll leverage on the MONAKA chipset to probably even drive what comes after Fugaku probably.
Okay, that would be my next question, right? So also targeting HPC and high-end.
Yeah,
yes.
MONAKA will be very fast.
Yes.
It'll be very fast. It'll probably deliver the same or equivalent performance that A64FX does. But speed is not the only goal. It has to be. Its power consumption is another one. I mean, Fujitsu is huge on sustainability. So if we were to shut our eyes to that, we could probably develop that at half the cost that we're intending to spend on it. So we're spending a lot of money to make sure it's using much less power than anything else in the market does, and it'll be very fast. But that is not the only goal.
So speaking of next-gen systems, computational milestones can be very exciting and inspiring, and we just passed a big one here at ISC with a new Exascale system.
Yeah.
What is your view? What is Fujitsu's view? Your view of Exascale and Fujitsu's role in it?
Well, look, if you look at, for us, where Fujitsu's headed as a company, and I say that because it will put the whole question in context of we want to be the partner of choice for our customers in their digitalization journey. And for that, we also are, we want to be, we are a global company with Japan as its headquarters, and technology sits at the heart of what we do. And compute obviously becomes very important. So I think getting the latest cutting edge technology is extremely important, but I think for us, like being number one in top 500 or Exascale is one parameter, but that's not the only parameter, right? I think we are looking at how does it help our end users, our customers, how does this improve the performance of the overall portfolio. So I think there are a couple of actions in play, and it's a balancing act for us, right? As I mentioned, MONAKA will be a processor that will be open to a lot of much wider data set. It will be very open. And perhaps the next generation of chips and the next what we build with Recon might be something that challenges probably again top 500 number one position with Exascale systems. And maybe that's I won't talk too much about it, but that's where we go. But it has to be set in context of what do we use these systems for.
Right, so that's a perfect segue that as cool as the hardware is, it's ultimately about what you do with it and ideally helping society. Could you tell us a little bit about what Society 5.0 is and how Fujitsu is helping with that project?
So Society 5.0 is a concept, right? I mean, how do you bring technology and make it more digitalized and leverage and make it more human-centric, if you will, right? Not technology for technology's space. So as I mentioned, and DX plays a very important role in that, right? Because the digitalization of the society becomes extremely important, and it has to benefit everyday citizens. And I would say perhaps the best way to relate to that is what we are doing with Kawasaki City, which is in a smarter city context, because that is a good example of Society 5.0. So what we are doing is we're building a technology framework where the city wants to provide end user services that every citizen can benefit from, and at the same time reduce the carbon footprint. Help citizens lead a more healthy life. And for that, what we're using is we're using our the 5 technologies we have. You're using a 5D technology, collect the data, pass that data over public cloud, run that over digital twins, run the simulations on HPC, use our AI, and come up with certain offerings that the city can take it to its citizens. For example, hey, if you put a small solar panel on your rooftop or a small wind turbine and the power that it generates, how much does it help you and the city and the society in reducing the carbon emissions? And when you simulate that on the city level, how does that work? Or traffic. And then I give you points, or the city gives the citizen points that they can go and cash it in the retail stores or whatever they want to buy. And that completes the technology plus the business model as a complete cycle. Now, I think it's a pretty innovative concept. The platform that technology plays a very, very important role, and that technology is built by us. And it's not just for Japan. It's something that I think cities, in UK, in Europe, as well in Australia, looking at it as to can we leverage on that. But that's just one concrete example of where Society 5.0 can help, I guess, all the stakeholders, if you will.
Yep, and that's a great example of a public-private partnership.
Yeah,
yep.
Exactly.
Well, are you having a good ISC here in Hamburg? Is there any highlights that have stood out to you?
No, I have really enjoyed it. And I'll say why, because it's been a wonderful occasion to connect with customers and our partners, and I think for us, for me personally, and for Fujitsu, it has been a platform for reconfirming our strategy. I think everybody that we talk to, they kind of, hey, that makes like compute as a service platform, or computing workload broker, or what we see with you bring HPC to a much wider scale, and what we are doing with Fujitsu-MONAKA, and having computing and network and AI and security and converging technology, Society 5.4, all being interrelated. So it's been very good both for customers, really kind of talking to our partners, a lot of folks that are invested in HPC, and we also have customers in Hamburg itself, like Port Authority of Hamburg, right? That it's been good to connect with them, and it's been good. It's been really good.
Thank you so much for joining us, Vivek, and thank you for joining HPCwire at ISC in Hamburg. Tschüss.
Thank you for having me. It's been a pleasure.